Hi students, this is Ms. Johnson with 10-2 Simplifying Radical Expressions, Day 1. Our swabet for today is we are going to simplify radical expressions with numbers and fractions. Alright, let's get into our first example. We are going to simplify each expression. And problem example A is square root of 72, and the square root sign really should have the square root going all the way across the problem. My computer just wasn't typing it, I'm sorry. So square root of 72. So we want to break these down into perfect squares as much as possible. Remember, perfect squares are numbers that multiply by itself to give us the given number. So square root of 72, I can break this down, I can factor this into square root of 9 and 8. And you can either write both of them underneath the same square root sign, or we could write square root of 9 times square root of 8. Either way is acceptable, whatever your preference. My preference is the first way, so I'm going to go with that. Square root of 9. Well, I know that's a perfect square, because 3 times 3 is 9. So the square root of 9, we can now have the whole number 3 out front of the radical sign, and we can go 3 square root of 8. Now I can keep going with the square root of 8. I know that the square root of 8 is 4 times 2. And now I have another perfect square. I know the square root of 4 is 2. So that's another whole number out front. So what we can do is we can go 3 times 2 out front, which is the square root of 4, and we need to leave this square root of 2 underneath the square root sign. 3 times 2 is 6, so my answer is going to be 6 times the square root of 2. Okay. All right, moving on to my next example. We have 8 times the square root of 36. Square root of 36. All right, well, I know the square root of 36 is actually a perfect square. It is 6. So what we're going to have is 8 times 6, and now there's nothing left underneath the square root. 8 times 6 is 48. There is my answer. We are done with this one. Oops, wrong way. Let's try this way. All right, example number 2. All right, example A, we've got square root of 2 times the square root of 24. With these square roots, it is okay to multiply them directly across. So square root of 2 times square root of 24 gives us the square root of 48. Now we can go ahead and break it down into perfect squares like we did the first example. Okay, square root of 48. Let's see, there's a whole bunch of things that multiply to 48. I think I'm going to go with 4 and 12 because I know 4 is a perfect square. So square root of 4 times 12. Square root of 4 is 2. So now we're going to have 2 times the square root of 12. But I think I could factor square root of 12 down more. Square root of 12 can be broken down into 4 times 3. I know the square root of 4 is 2. I'm going to go right up here. So square root of 4 is 2, so now we have 2 times 2 in front times the square root of 3. 2 times 2 is 4, so our answer is going to be 4 times the square root of 3. All right, problem B. Now we've got numbers and square roots being multiplied by one another. 7 times the square root of 30 times 2 times the square root of 6. All right, well, what we're going to do first is it says to multiply, and we can multiply everything. And I kind of like to think about the square roots, the radicals, kind of like what's underneath would be like a variable. We can think about this as 7x times 2y. Okay, the things underneath the square root are different, so they'd be different variables. Can we multiply 7x times 2y? Sure, just like we can multiply these. Okay, we multiply the whole numbers together, and then we're going to multiply the variables. We're going to do that same thing with our square roots. We're going to multiply the whole numbers, 7 times 2, to get 14. Then we're going to do the square root, and we're going to multiply 30 times 6 to get 180. Okay. All right, now let's go ahead and factor. Let's see, square root of 180. I know 9 goes into 18, so 9 goes into 180 10 times. I'm sorry, 20 times. So we're going to have 14 times 9, or times the square root of 9 times 20. Well, we got a perfect square. Square root of 9 is 3. So now I'm going to have 14 times 3 times the square root of 20. All right, well, square root of 20, we can break those down into some factors that have perfect squares. I know that square root of 20 can be broken down into 4 times 5. Square root of 4 is a perfect square, and that's 2. So now we've got 14 times 3 times 2 out front, and the square root of 5 still stays underneath the square root symbol. Let's see, let's do some math. 14 times 3 is 42, times 2 is 84, so our answer is going to be 84 times the square root of 5. All right, few steps, but just keep thinking about those perfect squares, and we'll get there. All right, example number 3. We're going to go ahead and simplify these, and now we have some dividing. Square root of 3 divided by the square root of 8. Now, when we have fractions, we cannot have a radical sign in the denominator. Okay, can't have that. So what we're going to do is we are going to multiply by the denominator, which is square root of 8. Oh, let me write it over here, sorry. We're going to multiply by the square root of 8 on the top and the square root of 8 on the bottom. The reason we can do this is because square root of 8 divided by square root of 8 is 1. When we multiply by 1, things don't change. But here's why it's cool. Square root of 3 times square root of 8 equals square root of 24. Square root of 8 times square root of 8 gives us square root of 64. Square root of 64, that's a perfect square. Square root of 64 is 8. So we're going to have square root of 24 over 8. And actually, you can most of the time just skip writing down this step of putting square root of 64 and just know that a square root times the square root of the same number equals just that whole number without the square root sign. It's kind of a nice little shortcut. All right, let's see, square root of 24 over 8. I think we can keep going with square root of 24. We can break that down into factors of 4 times 6, and it's still over 8. All right, square root of 4, that's a perfect square, that's 2. So we're going to have 2 square root of 6 over 8. And we're pretty much done, but as we take a look at this, 2 over 8, we can simplify that, just like it's the fraction 2/8. We can simplify that to 1 over 4. So we can write this as 1 square root of 6 over 4. Or we could just leave off the 1 and we can just put square root of 6 over 4. Either way is totally acceptable, just like writing a 1 in front of a variable. You can put it, but it's certainly not needed. All right, part B. Okay, now we have square root of 2 divided by square root of 7 equals square root of 7 divided by square root of 3. All right, so we've got fractions and square roots and multiplying and dividing and all this fun stuff. What we're going to do is we're going to start by multiplying straight across. Okay, square root of 2 times square root of 7 gives us square root of 14, and square root of 7 times square root of 3 is square root of 21. All right, let's see, perfect squares. No, 14 doesn't have any perfect squares. 21, that doesn't have any perfect squares. So all we can do is we can actually break this down and just simplify it. Okay? We can divide this by 7, because 7 goes into 14, and divide this by 7. And so we can have square root of 2 over square root of 3. Okay? But if we remember, we can't have radical signs in our denominator. So just like example A, we need to multiply by the denominator. Multiply by square root of 3 over square root of 3, and we get square root of 6 over 3. And that's as far as we can go. All right, well, let's go ahead and do our summary. You can do it right now in your notes. You can do it on a summary sheet or in a foldable study guide. Thanks for tuning in. This was Square Roots and Radicals, Solving and Simplifying.